Alright, so in this video we're going to learn how to use the analytical method in order to add vectors together. And when you're working with distance values, that's actually the same thing as finding the displacement. If you remember from the tip to tail video, when we drew in the resultant vector, we essentially found the distance between the beginning of one vector and the end of the other. And that is the same thing as a displacement when you're dealing with distances. Now you can add other types of vectors together, but conceptually, adding together distances makes the most sense with this process, which is why we're starting with distances. So don't be shocked if you have to add other vector quantities together in the homework. Alright, so the first thing I'm going to do is I'm going to draw my vectors on a coordinate system. So we have north, east, south, west. I use a different color now. So vector A is north of west. So I'm going to go west and sweep north of it. So this is my 45-degree angle in here. This is my 5 kilometers. Vector B is due north. So that's just north here. So this is vector B. And then vector C here is south of east. So I'm going to point east and sweep south. So 9 kilometers. And this is the 55 degrees in here. So you always point in the direction of the second letter and sweep in the direction of the first. Now we're going to use the right triangle trig that we learned in topic 1. So our first step here is to break our vectors down into x and y components. So since vector A is in the negative x, I'm going to draw it to left in positive y, and I know that because I'm in quadrant 2 in A of y. And since I have the hypotenuse and I'm looking for the two sides, I'm going to use cosine and sine to do this. So we're going to say a of x is equal to a times the cosine of theta. So we're just using cosine equals adjacent over hypotenuse. The hypotenuse is always going to be the magnitude of the vector. And so if you take out your calculator and take 5 times the cosine of, I should actually put an angle in here, 45 degrees, you would get 3.54 kilometers. Now, vector component of A in the x direction is pointing in the negative direction. So we're going to put a negative sign there. That is not going to come out of your calculator. And we're going to say that the y component is equal to a times the sine of theta, because in this case the y component is opposite to the angle provided. I urge you to be careful about thinking about x as adjacent and y as opposite. A lot of times it is, but it isn't 100% of the time. Alright, and a of y is in the positive y direction, so we can leave that positive. The reason that the numbers are the same is because it's a 45-degree angle. Alright, so vector B is a little bit tricky. Vector B is entirely north or along the y-axis. So that means that the x component of B is going to be 0, and all of the vector is going to point in the positive y direction. These ones are a little bit more straightforward because you don't have to do any math to get them, but because you get in the habit of doing the math, and you don't have necessarily an angle to plug in, they are a little bit trickier. And then finally for vector C, we are in the 4th quadrant, which is going to be positive x, but negative y. So we're going to say C of x is equal to a, and x is adjacent, so we're going to use cosine. And we want to use C back here. So we're going to say 9 kilometers times the cosine of 55 degrees. And that is going to equal 5.16 kilometers. And that's pointing in the positive x, so I don't have to worry about the sign. And then we're going to say c of y is equal to c times the sine of the angle, because the y component is opposite to the angle provided. And so we're going to do our 9 kilometers times the sine of 55 degrees. And that's going to give us 7.37 kilometers. And since that's pointing in the negative y direction, we're going to put a minus sign out front. Now that we have the amount of the vector in the x direction and the amount of the vector in the y direction, we can add x's together and we can add y's together. And we're able to get the components of our resultant vector. Resultant is a fancy math word for the answer to an addition problem. So r of x is going to equal, in this case, a of x plus b of x plus c of x. So we're going to take the negative 3.54 kilometers plus 0 plus 5.16 kilometers. And this is going to equal to 1.62 kilometers. And then for ry, we're going to add together our y components. So a of y plus b of y plus c of y. So we're going to take 3.54 kilometers plus 7 kilometers plus a negative 7.37 kilometers. And this is going to equal 3.17 kilometers. Now that we have our components of our resultant vector, we need to find the magnitude of the direction of that resultant vector. So I'm going to draw a new coordinate system here. And I'm going to draw in my components. And I always do the x one first. So I'm going to draw along the x-axis r of x. And then off of the tip of r of x, I'm going to draw r of y. So it's positive y, so I'm going to draw it up. And we end up in the first quadrant. So this will be our magnitude of our vector, which is hypotenuse of the triangle. And then we're going to find our angle theta here. So we're going to use Pythagorean Theorem in order to find the magnitude of the vector. So we're going to take our 1.62 kilometers squared plus our 3.17 kilometers squared, so that our resultant vector magnitude is 3.56 kilometers. And for the angle, since we have the sides of the triangle, we're going to use inverse tangent. So we're going to do r of y, which is opposite, over r of x. Which means we're going to do 3.17 kilometers over 1.62 kilometers. Which is going to give us 62.9 degrees. Now you always have to give a reference point for your angle. So I'm going to say north of east. So you always point in the direction of the second letter and sweep in the direction of the first. So we point east and we sweep north in order to get to the resultant vector. You can also say above the positive x-axis, but you do have to give some sort of reference point of where you would put your protractor if you're actually measuring that angle. Now I do want to briefly mention subtraction here. What happens if I had said what's a plus b minus c? The only thing you're going to do that is different is once you get to this step where you have your components, you would flip the signs of the vector that is being subtracted. So since c is being subtracted, I would make this negative, I would make this positive, and I would continue with the component method. So you just flip the signs of the components of the vector that is being subtracted. Everything else is the same as addition for the analytical method.